In box 9.1, we have a really good definition of what pH is. Now, this goes for any sort of pH, but we're going to be thinking about soil pH. What you need to understand about soil pH is that pH is simply a reading of how many hydrogen ions or hydroxyl ions, but we're really reading the concentration of hydrogen ions in a solution. Now, we don't. The soil itself is not a solution, but there is water in the soil, and it makes a solution. So we can determine the hydrogen ion concentration. So here we have hydrogen ion on this graph. The hydrogens that are floating around in the water, and so just as we've discovered last chapter that we measure things in terms of moles, we are actually measuring the concentration of hydrogen ions in moles of hydrogen ion per liter of water. So we call that molar. And you can see that right here. Right, oh, right there. So you can see that moles per liter is our measurement. When the pH is 7, so when that happens, so for pure water, for instance, the pH is 7, and what that means is that the concentration, but the whole story is not just about hydrogen. The whole story is hydrogen and OH, or the hydroxyl ion, the OH ion. And obviously, if you put those two together, you get water. And so there's some discussion in this paragraph about how that plays into to water dissociating and those sorts of things. What you need to understand is that that as the number of hydrogen ions increase in the soil, we get a lower pH. So we get an acidic pH. If we're at pH 5, what that means is that we are acidic, okay? And it also means that we have high hydrogen amounts in the soil solution, in the soil water. Now later on we're going to think about what's actually on the soil. We just got through talking about colloids in the last chapter, and now we're thinking about hydrogen as a cation, and there is activity between the hydrogen cation and the colloid, and there's some interesting things that go on there, and we'll discuss those in a little while. Right now, what we're thinking about is just when we go more acidic, and this is another funny thing. If I say this soil is more acidic than the other soil, what I'm really saying is it has a lower pH number. So if I had a pH of 4 on soil A and a pH of 7 on soil B, the pH of 4 is quote-unquote more acidic, even though the pH number is lower. Okay, so we're way over here, and it means that we have a hydrogen concentration that's fairly high, very high. Okay. The other thing to note is that the hydrogen concentration in the soil, when we're measuring a pH, we're measuring that hydrogen ion concentration in the soil. Basically counting. Our measurement is counting how many hydrogens are in the soil water. If there's lots of hydrogens, we have a lower pH. We have more acidic conditions. If there's not a lot of hydrogens, we have a basic condition, or a higher pH. So the right side of this graph here. But it's a relationship between hydrogen and the OH ions, the hydroxyl ions. And as we increase the number of hydrogens, we have a similar decrease in the number of hydroxyl ions by the nature of how pH works. And you need to note that it's not actually a linear relationship. You see this little thing here that says logarithmic scale. So what that means is we are what looks linear here, what looks straight. So what looks like, oh, if we go this way, one unit, we're going to go, we're going to have a linear increase in hydrogen ions. That's not necessarily how it is. Really, we're exponentially increasing the number of hydrogen ions there. So it's not like when we go from seven to six, we're going down a couple of moles, and then here we're going down a couple of moles, and here we're going down two. It's not like two. Between these concentrations, it's more complicated than that, and it has to do with trying to help this make sense to us in a simple way by converting it to a scale that looks something like we understand in terms of how graphs are, and so just know that's not really important to what we're doing here, but just know that behind this is a huge increase. Actually, here we go. So let me see if this is spelled out in here. So it's actually not listed in this text, this idea of logarithmic scale, but you will have learned that, or will learn that in your other math coursework. But here's one place that it applies.